Hello students, I hope you all are doing fine out there. So we are doing exercise 21E, isn't it? Exercise 21E, and in our previous videos we have completed till question number 5 of 10. Okay, so today we'll start from question number 6 onward. So let's begin. So this is question number 6 of 10. We are asked to prove this equals to tan A plus cot A. We have root under sec square A plus cosec square A in the left hand side, and we are asked to prove this equals to tan A plus cot A, isn't it? So let's begin. LHS equals to root under sec square A plus cosec square A. So this can be written as 1 upon cos square A, isn't it? Because sec theta is the reciprocal of cos theta. So sec theta means sec A can be written as 1 upon cos A. So sec square A is 1 upon cos square A. Similarly, cosec square A can be written as 1 upon sin square A, isn't it? Because sin theta cosec theta equals to 1 upon sin theta, isn't it? Sin theta and cosec theta are reciprocal of each other. So this gives us, let's take the LCM of the denominator, cos square A into sin square A. So cos square A into sin square A. Here cos square A into sin square A gives us this cos square A sin square A. So sin square A into 1 sin square A plus sin square A into cos square A gives us this, isn't it? So cos square A into 1 cos square A. So root under sin square A plus cos square A means 1, isn't it? Sin square A plus cos square A, sin square theta plus cos square theta equals to 1. This is the formula, isn't it? So if the angles are same, then sin square A plus cos square A should be equal to 1. So in the denominator we have cos square A into sin square A. Okay, so let me continue here. This means root under 1. Root under 1 means 1, isn't it? 1 cubed means 1. 1 to the power anything is always 1. Okay, 1 to the power 100 equals to 1. So root under 1 means 1 to the power half. 1 to the power half means 1. Okay, 1 to the power anything is always 1. 1 to the power 0 is also 1. Okay, 1 to the power any number is 1. 1 to the power x is 1. So root under 1 means this root applies to both the numerator and the denominator. Root under 1 means 1 to the power half. 1 to the power half means 1. Okay, so root under 1 is 1 upon, now we have cos square A, sin square A. So when we remove the root, this cos square A becomes cos A, isn't it? And sin square A becomes sin A. Okay, sin square A becomes sin A. Cos square A, root under cos square A, sin square A becomes root under cos A into cos A into sin A, isn't it? Okay, now this cos A make a pair and remove the root. We have cos A into sin A, make a pair and remove the root. We have sin A, cos A into sin A. Okay, root under cos square A, sin square A becomes root free cos A sin A. I hope you got this. Now we have 1 upon cos A plus sin A, but we need tan A plus cot A, isn't it? So let us put the formula again. 1 means sin square A plus cos square A. 1 can be written as sin square A plus cos square A upon cos A sin A, cos A into sin A, isn't it? So this cos A sin A is whole upon this. This means sin square A upon cos A sin A plus cos square A upon cos A sin A, isn't it? If we take the LCM, cos A sin A, it becomes cos A sin A, and this comes here, isn't it? Like if I have 1 upon 1 upon A plus 2 upon A, okay, 1 upon A plus 2 upon A, LCM A becomes A, okay, so A into 1 is A, so 1, A into 1 is this A, that 1 into 1 is 1, plus this plus comes here, A into 1 is this A, that 1 into 2 is 2, so 1 plus 2 upon A. Same thing here, LCM, the same numbers like AA, cos A sin A, so LCM will be cos A sin A, this means 1 plus 2, isn't it? Sin square A and cos square A, we can write in this way. So here we have sin square A, and in the denominator we have sin A, so we can cancel 1 sin A and 1 sin A. So sin A upon cos A means tan A, isn't it? Sin A upon cos A is tan A. Tan theta equals to sin theta by cos theta, isn't it? So sin A upon cos A is tan A, plus here we have 1 cos A and here we have cos square A. So cos A and cos A can be cancelled. So here cos A upon sin A, cot theta means cos theta upon sin theta, isn't it? So cos A upon sin A means cot A, tan A plus cot A. So this is what we have in the right hand side, equals to RHS, hence proved. I hope you got this. Now let us do question number 7 of 10, okay? Question number 7 of 10. So we have sin A plus cos A into sec A plus cosec A in the left hand side, and we are asked to prove this equals to 2 plus sec A into cosec A, isn't it? So let's do this. LHS equals to sin A plus cos A into sec A plus cosec A, isn't it? So this is left hand side and we are asked to use this and prove this, isn't it? So let's do this. Sin A into sec A. First I multiply these two numbers with sin A, and after that I multiply cos A with these two numbers, okay? So sin A into sec A is sin A into sec A, okay, plus, so plus into plus, plus, sin A into cosec A is sin A dot cosec A, dot means into, okay. Now I multiply with this cos A, okay. So plus into plus is plus, cos A into sec A is cos A sec A, cos A sec A, plus cos A into cosec A is cos A cosec A. Now I write this sin A as it is, okay, this sin A. Sec A means 1 by cos A, isn't it? So this can be written as upon cos A. Sec A equals to 1 by cos A. Cos and sec are reciprocal of each other, so sec A can be written as 1 by cos A, okay. So sec A was in the numerator, I bring down to the denominator, it becomes cos A, plus sin A into cosec A is 1, okay. Sin theta equals to 1 upon cosec theta, isn't it? Sin theta and cosec theta are reciprocal of each other, so let's cross multiply this. Sin theta into cosec theta equals to, we have 1 in the right hand side. Sin theta into cosec theta equals to 1, okay. Similarly, cos theta into sec theta is also 1, because cos theta equals to 1 upon sec theta. So cos theta into sec theta gives us 1. So sin A into cosec A can be written as 1, plus cos A into sec A 1, plus this cos A I write as it is, cos A. Now cosec A means 1 upon sin A, isn't it? So this becomes sin A. Cosec A means 1 upon sin A, okay. Cosec theta equals to 1 upon sine theta, isn't it? So cosec A, if I bring down this cosec A to the denominator, it becomes sine A. Now sine A by cos A by sine A, sine A by cos A plus cos A by sine A, cos A by sine A, plus I write this before, and the 1 plus 1 is 2. Okay, plus 1 is plus 2. Now let's take the LCM of these two denominators, cos A into sine A, cos A into sine A. Now cos A into sine A gives us cos A sine A, that means sine A into sine A, sine square A, plus sine A into cos A gives us cos A sine A, so cos A into cos A, cos square A, plus 2, isn't it? So let me continue here. Sine square A plus cos square A, sine square A plus cos square A means 1, isn't it? Sine square A plus cos square A can be written as 1 upon cos A sine A, cos A sine A. Okay, sine square A plus cos square A is 1, and cos A sine A, plus 2, plus 2. So cos A, if I take this cos A to the numerator, it becomes sec A, because cos theta and sec theta are reciprocal of each other. Similarly, if I take sine A to the numerator, it becomes cosec A, plus 2. So sec A into cosec A plus 2, sec A into cosec A plus 2, isn't it? This is equals to RHS, hence proved. Sec A cosec A plus 2, sec A into cosec A plus 2, sec A into cosec A plus 2, same thing. Okay, 2 plus 3 and 3 plus 2, same thing, isn't it? Either you write 2 before and sec A plus cosec A later, or sec A plus cosec A before and 2 later, the same thing. So I hope you got this. Now let us do question number 8. Okay, let's do question number 8 of 10. So we have tan A plus cot A into cosec A minus sin A into sec A minus cos A in the left hand side. So we are asked to prove this equals to 1 in the right hand side, isn't it? So let's do this. So LHS, let me copy the left hand side first. LHS equals to tan A plus cot A into cosec A minus sin A into sec A minus cos A, isn't it? So these are the numbers in the left hand side, isn't it? So tan A can be written as sin A by cos A, because tan theta is sin theta by cos theta, isn't it? Tan A is sin A by cos A, plus cot A is cos A by sin A, isn't it? Cos A by sin A. Cot theta can be written as cos theta by sin theta. So this cosec A, I convert this to sin A form. Okay, cosec A, if I take down this cosec A to the denominator, it becomes sin A, isn't it? Because cosec theta and sin theta are reciprocal of each other. So cosec A, if I take down to the denominator, it becomes sin A, 1 upon sin A, minus sin A. So sec A is 1 by cos A, isn't it? Because sec theta and cos theta are reciprocal of each other, so sec A means 1 by cos A. If I take down this sec A to the denominator, it becomes cos A, okay, minus cos A. So let's take the LCM of these two denominators, cos A into sin A, cos A into sin A. Okay, now cos A into sin A gives us this cos A sin A, isn't it? So sin A into sin A is sin square A, plus sin A into cos A gives us cos A sin A, so cos A into cos A is cos square A. Okay, so here we have 1 in the denominator of sin A, so LCM of sin A and 1 is sin A. So sin A into 1 gives us this sin A, so 1 into 1, 1, minus 1 into sin A gives us sin A, so sin A into sin A is sin square A, isn't it? here we have 1 in the denominator of cos A. So LCM of cos A and 1 is cos A. So cos A into 1 gives us cos A, that means 1 into 1, 1 minus 1 into cos A gives us cos A into cos A, cos square A. So sin square A plus cos square A means 1, isn't it? In the denominator we have cos A sin A, cos A sin A, into 1 minus sin square A is cos square A, isn't it? Sin square A plus cos square A equals to 1. That means cos square A equals to 1 is already in the right hand side. So let's take this sin square A, becomes minus sin square A. So 1 minus sin square A is cos square A. So instead of 1 minus sin square A, I can write cos square A. In the denominator I have sin A into 1 minus cos square A is sin square A, isn't it? So if I take this plus cos square A to the right hand side, 1 minus cos square A, sin square A equals to 1 minus cos square A. So 1 minus cos square A means sin square A upon cos A. So we have cos A here, isn't it? So this cos A and this cos square A. So cos A into cos A, cos square A and cos square A, okay? Cos A into cos A, cos square A in the denominator, and we have cos square A in the numerator. So we can cancel these two cos A and cos square A. Okay, now here we have sin A into sin A, sin square A, and in the numerator also we have sin square A. So sin A, sin A, sin square A. So we have only 1 left, isn't it? 1 into 1 into 1. 1 into 1 into 1 is 1. In the denominator also we have 1. So 1 upon 1 means 1. So this is what we have in the right hand side, equals to RHS. Hence proved. So let's do question number 9. Okay, now let us do question number 9 of 10. Okay, so cot square A minus cot square B equals to cos square A minus cos square B upon sin square A into sin square B equals to cosec square A minus cosec square B. So we are asked to prove this equals to this, and again this equals to this, isn't it? So we are asked to prove 2 times. Okay, first we need to prove this equals to this, and after that we need to prove this equals to this. So 2 questions, okay, at a time. So let's do this. First we prove this 2. LHS equals to cot square A minus cot square B. And please note that A and B are not complementary angles here. Okay, A and B is not a complementary angle. Complementary angle means sum of those 2 angles should be equal to 90 degree. If I write A and B, if A and B are complementary angles, if A and B are complementary angles, then sum of these 2 angles should be equals to 90 degree. But in this case it is not given that A and B are complementary angles. So we cannot consider A and B as complementary angles. So let's solve as it is. Okay, so cot square A is cos square A upon sin square A, because cot theta means cos theta by sin theta. So cot square A is cos square A upon sin square A, minus cot square B means cos square B by sin square B, isn't it? So let's take the LCM of the denominators. Sin square A and sin square B, sin square A into sin square B. Okay, so we have sin square A, sin square B here, so we need not change now. Now sin square A into sin square B gives us this, so sin square B into cos square A. This means cos square A into sin square B, minus, so sin square B into sin square A gives us this, so sin square A into cos square B, sin square A into cos square B. Okay, so this is cos square A, cos square A. Now sin square B means 1 minus cos square B, isn't it? Sin square b means 1 minus cos square b. Please keep in mind that angles should be same, okay? B. Angle is B. Sin square b means 1 minus cos square b. Sin square theta means 1 minus cos square theta, because sin square theta plus cos square theta, here angle is theta, please keep in mind angle is theta. Sin square theta plus cos square theta is 1, angle should be same. So sin square theta, sin square theta equals to 1 plus cos square theta goes to the right hand side, becomes minus cos square theta. So sin square theta is 1 minus cos square theta. Theta and theta should be same, then only we can apply this formula. So sin square b means 1 minus cos square b. We cannot write 1 minus cos square a, okay, because angles will be different in that case. So this minus comes here, this sin square a into cos square b, whole upon we have sin square a into sin square b. Now cos square a into 1, cos square a, plus into minus, minus cos square a into cos square b, cos square a, cos square b, okay, minus sin square a into cos square b, sin square a into cos square b, whole upon, in the denominator we have sin square a, sin square b, sin square a, sin square b. Now let me continue here. I write this cos square a as it is, okay, cos square a, this equals to cos square a minus, here you can see cos square b, here also you can see cos square b, isn't it? So let's take cos square b common, minus cos square b common, okay, minus cos square b. So here we have cos square a, cos square b, and cos square b is taken common out, so cos square a remains within the bracket, cos square a. So minus into plus, minus into plus, minus into plus gives us this minus sign, isn't it? Minus into plus gives us this minus sign. Now sin square a into cos square b, these two numbers are here, so cos square b is taken out, now sin square a remains within the bracket, sin square a, isn't it? In the denominator we have sin square a, sin square b, sin square a into sin square b. Now cos square a minus cos square b, this cos square a minus cos square b, cos square a plus sin square a. See here the angles are same, isn't it? A. So cos square a plus sin square a means 1, okay, upon sin square a, sin square b, sin square a dot sin square b. So cos square a minus cos square b into 1, cos square b, upon sin square a, sin square b. So one condition is proved, okay, this is this, so equals to RSS, hence proved. Now let's prove this equals to this, okay. So please take the screenshot, I'm going to erase this. Now I'm going to use cot square a minus cot square b and prove this equals to cosec square a minus cosec square b. Okay, now let's prove this cot square a minus cot square b equals to cosec square a minus cosec square b. Okay, so cot square a means cosec square a minus 1, isn't it? Minus cot square b means cosec square b minus 1, isn't it? Since I'll explain this here, cosec square theta minus cot square theta equals to 1. This is the formula, we know this, isn't it? Cosec square a minus cosec square theta minus cot square theta is 1. So instead of cot square A, okay, cot square A I take to the right hand side, cosec square theta, this one I bring to the left hand side, minus 1. Now minus cot square theta goes to the right hand side, becomes plus cot square theta, isn't it? So cot square theta is cosec square theta minus 1. So cot square A is cosec square A minus 1. Cot square theta is cosec square theta minus 1. Cot square A is cosec square A minus 1, isn't it? Similarly, this minus sign comes here. Cot square B means cosec square B minus 1. I hope you got this. Now we have cosec square A minus 1, minus into plus, minus. No sign means plus, isn't it? There is plus sign in front of cosec square B. So minus into plus, minus cosec square B. Cosec, this is not cos, this is cosec, okay? Cosec square B. Minus into minus, plus 1. Now we have minus 1 and plus 1. So 0. So cosec square A minus cosec square B. Cosec square B. So this is what we were asked to prove. Okay. So this equals to RHS. Hence proved. I hope you got this. Now let's do another question. Question number 10 of 10. Okay. 10 we have cot A minus 1 upon 2 minus sec square A, and we are asked to prove this equals to cot A upon 1 plus tan A, isn't it? So let's do this. LHS equals to cot A minus 1 upon 2 minus sec square A, isn't it? So let's write this cot A as cos A by sin A, okay? Cos A by sin A minus 1 whole upon 2 minus sec square A 1 upon cos square A. Okay. So let's take the LCM of the denominators. Sin A into 1, sin A. Okay. So 1 into cos A, because sin A into 1 gives us sin A. So 1 into cos A minus 1 into sin A gives us this sin A. So sin A into 1, sin A. And in the denominator we have, so 1 and cos square A, LCM will be cos square A upon 1 into cos square A gives us cos square A. So cos square A into 2, 2 cos square A. Minus sign comes here. So cos square A into 1 gives us cos square A. So 1 into 1, 1, isn't it? So let me continue here. Cos A minus sin A. Cos A minus sin A. Now cos A minus sin A. Okay. Now this cos square A from the denominator goes to the numerator, isn't it? This cos square A. Suppose if I have A upon B upon C upon D, then what I write is A upon B into this D goes to the numerator and C comes down. So the number in the denominator D goes to the numerator. Similarly, this cos square A goes to the numerator. So cos square A. This number D goes to A, okay, in the same line, isn't it? A and D. Similarly, cos A minus sin A and cos square A should be in the same line, cos square A in the numerator. And in the denominator we have sin A upon this, sin A into this, okay. This is what we have in the denominator, 2 cos square A minus 1 into sin A. So sin A into 2 cos square A minus 1, isn't it? 1. So 1 means sin square A plus cos square A. Okay. So I use curly bracket here. So 2 cos square A minus 1, isn't it? First sin A, this sin A into 2 cos square A minus 1. because b into c, this b into c, b into c, you can see b into c. So b into c means this is b, this is c. Sin a into 2 cos square a minus 1, sin a into 2 cos square a minus 1. So 2 cos square a is this 2 cos square a minus, this is minus 1 means sin square a plus cos square a, because sin square a plus cos square a is 1, isn't it? So we have cos square a upon sin a, means cos a into cot a, isn't it? Cos square a means cos a into cos a upon sin a, sin a. So cos a is this cos a, okay, cos a by sin a is cot a. So cos square a upon sin a means cos a into cot a, okay, into we have cos a minus sin a, cos a minus sin a, isn't it? So here we have this sin a is gone because it become cot a, isn't it? So 2 cos square a, 2 cos square a minus into plus minus sin square a minus into plus minus cos square a, okay. This gives us cos a into cot a cos a minus sin a whole upon 2 cos square a minus cos square a. 2 cos square a minus cos square a means cos square a, okay. Sign of greater number comes here, plus 2 cos square a minus cos square a is cos square a minus sin square a, minus sin square a. Now this is cos a into cot a, we don't change anything in the numerator, we copy as it is, cos a minus sin a, okay. In the denominator we have cos square a minus sin square a, this means a square minus b square, okay, a square minus b square. We assume cos a as a and sin a as b, a square minus b square, which means a plus b into a minus b, isn't it? So cos a plus b, a plus b into a minus b, cos a minus sin a, okay. So this cos a minus sin a and cos a minus sin a can be cancelled. Now we have cos a upon cos a into cot a by cos a plus sin a. So we divide the numerator and denominator by cos a, because we don't need cos a in the numerator, isn't it? We need only cot a, okay. We divide numerator and denominator by cos a, dividing numerator and denominator by cos a. So cos a into cot a divided by cos a whole upon cos a plus sin a, cos a plus sin a divided by cos a, okay. This means cos a and cos a. We divide numerator and denominator by cos a. So this cos a and cos a can be cancelled. So please take the screenshot, I will continue here, okay. Cos a and cos a cancel. Now we have cot a in the numerator, this equals to cot a whole upon cos a by cos a cancelled, we have 1, so 1 plus sin a by cos a means tan a, isn't it? Sin a by cos a means tan a. So cot a upon 1 plus tan a, cot a upon 1 plus tan a, this equals to RHS, hence proved. I hope you got this. Thank you so much for watching this video. Stay connected. I'll upload the remaining questions in the upcoming video, okay. Thank you.